Hello all. Today we are going to see a question from GATE 2017 Mechanical Paper 1, question number 44. So you are given a horizontal bar which is fixed at one end at x is equal to 0 and it has length of 1 meter and cross sectional area 100 mm square. So you are given that your Young's modulus will vary in this particular function form where x is the length and it is in meter along the axis of the bar. So if there is some axial tensile load of 10 kilonewton at the free end, that is x is equal to 1, then you are supposed to find what is the axial displacement of the free end in mm. So this is related to the axial loading and strains due to the loading. So you can check out more details about these kind of problems in NPTEL course Strength of Materials by Professor S.K. Bhattacharya from IIT Kharagpur. So let's go ahead with the problem. So this will be the data that will be useful, that this is the condition given and you are given a load P. So your delta, that is the displacement, axial change in length or elongation you can say, is PL by AE. So let's see how to utilize this in our problem. So now let's consider some thin strip like this. Okay, so let's say its thickness is dx and it is at some distance x from free end. Okay, now important thing to notice here is your x is in meter. Okay, so your x is in meter. Your a that you are going to use should also be in meter. So let's say meter square, and the next thing is your e of x, that is in GPA. So that is in GPA, so you need to convert that into PA, because here sort of all the units are sort of mixed. So let's bring it down to the basic units. Okay, and then solve everything. Okay, so now we know that your let's say your delta x is the elongation for this particular strip, therefore that is equal to, so p into its length of the strip is dx by a into e of x, right? So now this you can write it as p into your dx by a into, now e of x is 100 e raised to minus x, right? So now what you need to do is, now you need to convert everything into proper units. Okay, so let's say total elongation is going to be integration of that. So now we are going to integrate it for the total length, 0 to total length. So what do you get here? Okay, so now p is going to be here and a into 100 e raised to x dx. So basically this is your integration. So p by 100a into e raised to x 0 to L. Okay, so what you're going to get is p by 100a into e raised to L minus e raised to 0. Now let's convert all the units into the basic units that I was talking about. So now delta is equal to P into, so 10 kilonewton, so 10 into 10 raised to 3 into e raised to L, so L is 1 meter. So now here your L is supposed to be in 1 meter unit, so let's say e raised to 1 minus e raised to 0 by 100. So now this point, this thing was in GPA, right? This thing, so you need to convert this back to PA. So here you're multiplying down by 10 raised to 9. Now what is your A? 100 square. So this you will convert it into 100 into 10 raised to minus 3 square. So that you are going to write it as into 10 raised to minus 3 square. Okay, so now you have successfully converted all the units. So now finally when you solve it, what you are going to get is 1.71828 into 10 raised to minus 3. We have converted everything into meter, so final answer also will be in meter. But actually they are asking you the answer in mm. So this will be again 1828 mm. So this is your final answer. If you want to know more details about this kind of problems, please check out the NPTEL lecture. So here the trick was like everything was actually the play of units. So here they are asking in mm, here they have given in GPA, here x is given in meter. So all these things were to confuse the person who is solving the problem. So if you want to just remain out of all this confusion, always change it into the basic unit like meter, PA, Newton, so that your final answers will be correct. Okay, so I hope you understood the problem. Thank you.